So you have a wheel and you have some Python and you want to make the wheel rotate as you move it. Well, guess what? Come to the right place, my friend. Let's do this. Okay, so we need to find out the bounding box of this wheel. Basically, that'll get us the diameter, and we can figure out the circumference, and from there we can figure out how many rotations it needs to do in order for it to be moved in translate x. So let's import maya.cmds as cmds, because why not? I want my selection to equal basically the selection that I have, and the index number is 0. If I had it as nothing, I would right now be selecting two things. I'd be selecting the cylinder and also the shape, and I don't want the shape. I just want this guy here. Okay, so now we need the bounding box. So my BB is, we're going to use X form, and then it's going to be my cell. We need the query equals true, because we want to know what value it has, and the BB equals true. So let me just get that here. So see, BB equals true. And when it prints out my BB, whoops, it's going to give me a bunch of numbers here, right? And since I'm a nerd and I know what all this stuff means, this is basically just minimum x, minimum y, minimum z, maximum x, maximum y, maximum z, right? So, and Python, how it works for index is this is 0, 1, 2, 3, 4, and 5. Even though there's 6 numbers, there's only 5 index portions, basically. So let's use y just for fun. So diameter equals the it's going to be the fourth, oops, yeah, the fourth index value, which is maximum y, minus the minimum y, which is 1. So that's going to be this guy here minus this one, which should give me a value of 2. So if I print out diameter, let's see what happens. Yeah, I get around to 2. Don't worry about this stuff. It's basically, this is all you really need here. Cool. So what is I want a circumference. So sure, equals diameter times pi, so 3.14. Print circ. So the circumference of this is 6.2800 stuff here. Perfect, right? So if I were to just print, like, make it so that whenever I translate this in x and rotate this in z, let's just say, like, it'd be pretty easy to do and be able to use this number here. And I'll show you what happens when that does happen. So it's not perfect. So we need to do some more calculations. But so we do multiply, divide node, and we plug in the translate, what was it, x? Let's see. Yeah, translate x into the input, and then the output is going to be rotate z, I believe. Yeah. So when I move this, it should be, so it's rotating, but it's not rotating that much. You can kind of see, there's a little bit of rotation. If I zoom it out, you should be able to see it a little bit more. See that? But it's going too slow, so we need to figure out what's going on here. Because it's multiplying by 1. So if you multiply it by the 6.28? Let's try this again. I want the, oh yeah, print out the circumference. 6.28, yeah, and then now we have it, we're multiplying by 6.28. You can see how it rotates a little bit, but it's rotating the wrong way. So we can fix that. Let's delete these guys in this unit conversion, and let's get a reverse node. Because it's going the wrong way, so we have to reverse it so it goes the right way. So output x goes to input x, and output x goes to rotate z. That makes sense, trust me. Just go with it. Look at that, perfect. Using math, we figured out a way to move this wheel so that it rotates whenever we move it. But it's going a little bit too slow. We need to multiply by pi again. So here we have 6.28, and 6.28 times 3.14 is 19.7192. So 19.71. So now when you remove it, that should be a little bit easier to do. See? Look at that. It's amazing. The stuff you can do with Node Editor in a little bit of time. So yeah, that's how to mathematically get the rotation of a wheel as you're moving it. And you're not using any expressions or any script. Well, you're using a script, but you're not, it's all Node Editor. It's all this stuff right here. And that is all I got for you guys today. See you next time.